Alright, so in this video, we solved the partial differential equation given by 3x partial of u with respect x plus 17t partial of u with respect t equal to 0, subject to the condition u of x1 equals to 7x to the 8th power. Again, we're going to solve this PDE using separation of variables. And for this, we're going to assume a solution of the form u of xt equals to the product between a function of x and a function of t, right? And again, we're going to take the necessary partial derivatives as required in the PDE, that is partial of u with respect x, that is the derivative of f, which is f prime times g, because we are differentiating with respect x, g remains constant. And the partial of u with respect t equals to f, which remains constant because we're differentiating with respect to t, and then g becomes g prime, right? Substituting this into the PDE, we get 3x f prime g plus 17 t f g prime, and let that be equal to 0, right? Okay, so again, the trick here is to divide both sides by the product fg to get the variable separated. That's going to leave us with 3x f prime over f plus 17 t g prime over g. And let that be equal to 0. All right. So in order to separate the variables, I'm going to move the 17g, the g term to the right hand side. That's going to leave us with 3x f prime over f equals to negative 17t g prime over g. And in this case, well, actually, I'm going to leave the x f prime of f by itself by dividing both sides by 3. That's going to leave us with x times f prime over f equals to negative 17 over 3 t g prime over g. And well, at this point, we have the variables separated. Now we need to set this equal to another constant of separation. That is to find a solution to the equation for the x variable and a solution for the equation for the g variable, for the g function rather, right? Which is where f is a function of x and g is our function of t, right? So let's solve the first equation. That is x f prime over f equals to k. Well, so I'm going to write this x 1 over f times f prime, which in reality is df dx, and let that be equal to k. So separating the variables, leaving all the f factors on the left and all the x factors on the right, that's going to leave us with df over f equals to k over x dx. And at this point, we may go ahead and integrate both sides of the equation, leaving us with ln of f equals to k ln of x, ln of x plus some constant of integration that I'm going to call c, right? So exponentiating both sides again to cancel the ln's, that's going to leave us with cancel e with ln again, and that leaves us with f equals e, okay, actually this e to the c is some c, and we wish we could cancel this e with ln. However, we can do that unless we don't have any coefficients in front of the ln. So using properties of logarithm, the coefficient becomes the exponent of the argument, leaving us with c e to the ln of x to the k. And at this point, we can cancel with e with ln, and f equals to cx to the k. All right, and we just solved the first equation, that is to obtain the solution for the factor f, which is a function of x. Let's do the same, but now to solve for to find the function g. That is negative 17 over 3 t g prime over g equals to k. And well, let's separate the variables, right? So that's going to leave us with 1 over g times g prime, which is really dg dt. Again, keep in mind, recall that g is a function of t. And then I'm going to multiply by the reciprocal of negative 17 over 3, which is negative 3 over 17. And this t, which is multiplying, I'm gonna divide both sides, and that's gonna be 1 over t. All right? And then k, and then this dt right here, I'm gonna multiply both sides by dt to get the equation dg over g equals to negative 3 over 17 times 1 over k, 1 over t, k dt. All right? Actually, I could write the the k and multiply it with the 3 over 17, negative 3 over 17. So we can go ahead and integrate both sides at this point. So that's going to leave us with ln of g equals to negative 3k over 17. Well, actually, this is supposed to be 1 over t. And then this is ln of t plus another constant of integration, and I'm going to call d. All right? And exponentiate both sides to get the ln cancel. However, here we cannot do such a thing. So that's going to leave us with g equals to e to the d, which is just another d, and all these coefficient, negative 3 over 17k, needs to go as the exponent of the argument in order to be able to cancel e with ln. All right, so that is e to the t to the negative 3k over 17, and let's cancel, or rather ln. Forgot the ln over here. Okay, need to make some space. E to the ln, and finally, let's cancel e with ln. And that's going to leave us with g equals to d t to the negative 3 over 17 k. And now we have obtained the two solutions whose product is going to be the general solution to the PDE. All right, so that is u of x t equals to the product between f and g, which is in this case c x to the k power d t to the negative 3 over 17 k. And again, absorbing c and d, u of x t equals to c times d, which is just another constant a, and that's x to the k t to the negative 3 over 17 k. And that is our general solution. Right, so now our job is to find the particular solution subject to the condition. Go back to the top to show the condition. U of x1, not a u of x0, u of x1 equals to 7x to the a. All right, so that is with u of x1 equals to a x to the u of x1 equals to 7x to the 8. That is, we're going to evaluate u of x1 on the general solution. That is, whenever we see the variable t, replace with a 1, keeping x unchanged, right? That equals um, a x to the k times really 1 to the negative 3 over 17k. But in this case, well, 1 raised to this number, whatever that number is, it's just going to be equal to 1. Let that be equal to 1. And that's going to leave us with a x to the k power. And u of x1, in this case, that is 7x to the 8th power. And again, equating coefficients and powers, we get that a equals to 7 and k equals to 8. Right? So a equals 7, k equals to 8. And we may go ahead and write the particular solution to the PDE. That is, go back over here, and u of xc equals to a, which is 7x to the k, which is 8, times t to the negative 3 over 17, k, which is 8. And in this case, just multiplying the numbers, 3 times 8, that's going to leave us with u of xt equals to 7x to the 8 times t to the negative 24 over 17. Final answer.